Hello and welcome back. So today in maths, we're going to be doing 4-digit numbers times by a 1-digit number. And as you can imagine, this actually isn't too bad. We've already got the models and methods sorted and in place and practiced. And all we're doing is adding that additional column that we have to think about. But as long as you remember our times tables, actually, this doesn't have to be that hard. So let's have a look. First off, we're going to do a little bit of arithmetic, just practice those skills from the last couple of days, stand us in good stead for today's lesson, and then move on from there. So first off, we have our arithmetic questions. Have a go at these questions and see what you can do. The first one is 20 plus 20 plus 20 plus 20. Then how else can I write this question? What's another way of writing the same thing? Then have a go at numbers 2, 3, and 4. And again, you can use any method you like in order to answer these. Pause now and have a go. Okay, so if we go through the answers, here they are. The first one for number 1, 20 plus 20 plus 20 is 80. Another way to write this is to see how many 20s we have. We have 4 20s, so it's the same thing as 4 times 20. The next one we have is 4 times 27. Now we can use our compact formalism method, we can use our expanded formalism method, or we can use our place value grid in order to help us with that. But the answer is, you do 4 times 7, which is 28. You add that onto the 4 times 20, which is 80, and that gives you 108. Then you move on and do 4 times 231. So 4 times 1 is 4, nice and easy, go straight into the units column. Then we do 4 times 3, which is 12. So we put the 1 in there and we make sure we're going to add 1 onto whatever the answer is of our hundreds column. We do 4 times 2, which is 8, plus that 1 additional 100, so we get 900. So it's 924. Then looking at number 4, we do 4 times 2, which is 8, goes into our ones column here. We do 4 times 60. Remember, we can think of that as 4 times 6. 4 times 6 is 24. So the 4 of that goes into our tens column, and the 6, because it's 60 tens, the 20 tens transforms 20 tens into 200s. We do 4 times 4, which would be 16, plus those 2 additional hundreds makes it 18, and we have no thousands, so there is our 18. Hopefully that was okay, but as we go through today, what you will see is we're still practicing the same methods as we've just used then, so you can see them as we go through. Let's have a look. So we're going to start with a reasoning question to begin with, and this is actually where we use the knowledge that we've got. So Ron and Teddy are working out 5 times 245. Ron says, I know the answer will be greater than 1,000 because I know 5 times 200 is 1,000. And Teddy says, I know the answer should end in a 5 because I know that 5 times 5 is 25. Who's correct? Is Ron correct? Is Teddy correct? Both of them correct? Or neither? And B, use your written method, one of them, in order to work out 5 times 245. Pause now and have a go. Okay, first off, let's go with they're both correct. We know that we're going to have to times each of these columns by 5. 5 times 5 is 25. That gives us what's going to be in the end column. So he's right, it's going to end in 5. And Ron knows that 5 times 200 is 1,000, so it must be over 1,000 because we haven't taken into account the tens and hundreds. So they're both correct. Then we can use our written method in order to find it out. We do 5 times 5, which is 25, and there's our 25, you can see it there. Then we do 5 times 4, which would be 20, but we're going to add that 2 onto it to make it into 22. That's plus adding that 2 there. And then finally, we can do 5 times 2, which is 10, plus that additional 2, which is 12, and there's our 12 because we have nothing else in the thousands column. So our answer is going to be 1,225. So our next question is to calculate 3,223 times 3. And this is where we come to the new learning, because this is our 4-digit number times a 1-digit number. We're going to go back through similar methods that we've looked at before. So what we need is a place value grid. And we have thousands, hundreds, tens, and ones. And because we're timesing by 3, we have 3 rows in which to put that number into. We can also write it in our column contracted method. Here's our columns, there's our number, that's what we're timesing by, and the answer will come down here. So let's put the counters in. 3,223. We need that 3 times, so there they go. Then, much like anything else, we're looking in the ones column, and we look at what 3 lots of 3 are. There are 9 of them, so 9 would go in our ones column. Then we do 3 lots of 20, or 3 lots of 2 tens. So 3 times 2 is 6, so we need 6 tens. There it is. Then we do 3 lots of 200s. 200s 3 times, as you can see over here. And yes, you're right, it is 6 hundreds. And then we do the same thing in the last column, which is 3 times 1,000, which is 3,000s. 3 times 3 is 9. So in total we have 9,000s, which you can see over here and goes in there. So our answer to this question would be 9,669. Exactly the same way that we've done in all of the others. All you have to do is apply the same principle, the same scaffold, the same model that we've used before to one more column. And it's not too bad, because we know the tricks and we know the way to use that pattern to make our lives easier. And remember, our times tables is the trick we need to know to make everything easier. So here we have a slight reasoning question. Let's have a look. I'm just going to hide myself for a second. So there are 2,114 seats in a theatre. The theatre is fully booked for 3 shows. How many people attend overall? So the first thing we need to work out is what's the sum. What's the calculation, sorry. So we've got 2,114 seats. We know that it's fully booked. All those seats are going to be full for 3 shows. So what we're doing, what's the sum? What's the calculation we're going to do? Have a think, try and answer it, and then we'll go through it together. Off you go. Okay, so the question is going to be 2,114 times 3. So let's put it into our place value grid and into our written method. We're going to do both. You could have just chosen to do one, but I'm going to show it in both. We put 3 rows because we're timesing by 3. Let's put our number in counters in our first row. There's 4, 110, 100, and 2,000. And obviously we need to do that 3 times. There we go. Then we can do our sums starting in the ones column as we always do. We do 3 lots of 4 ones. 3 lots of 4 is 12, which means we need to exchange 10 of those for 1 10. So 2 goes into our ones column and 1 goes into our tens column. And there you can see our 12. Then we move on to our tens column. We've got 3 lots of 1 10. So 3 lots of 1 is 3 plus that 1 10 there. In total, we have 4 tens. And there's our 4 tens. Then we do 3 lots of 100s. There's 3 lots of 100s. 3 times 1 is 3. So we have 3 hundreds. And finally, we look in the thousands column. We do 3 lots of 2,000s. 3 times 2 is 6. So in total, we have 6,000. It goes in there. And that's a written question using all our knowledge and up to 4 digits times by 1. Well done. We have 6,342 people. I'd like you to have a go at both of these 2 questions here. Use what you know and see if you can find the answers using either of the methods that we've used. Have a go now, pause now. Okay, so let's have a look. The first one says, complete the multiplication, use the place value chart to help you if you need to. So we've got 2,102 times by 4. Then our second question is, a football stadium holds 2,214 people. The stadium is full for 4 matches in a row. What attendance are all 4 matches? So we have to work out the question as well as the answer for that one. And then number 3, we've got Niger is counting 2,430 times 3. She makes a place value chart to help her out, and we can see it there. And she gets the answer of 729. What mistake has she made, and what's the correct answer? Let's have a look. So, first off, we have the first question. This would be what it would look like if we were having a place value chart. You can see the 2 in the ones, we've got none in the tens, we have 1 in the hundreds and 2 in the thousands, and we've got that 4 times, and that gives us the answer of 8,408. Classic error is this part here. A football stadium holds 2,214 people. It's full for 4 matches in a row. What's the attendance for 4 matches? So we can find out that we have to times this by 4. There's our question. We lay it out either this way or using this method, depending on which one you want to. And then we can do, as long as we do our exchange from 1s to 10s, our answer will end up being 8,856. And now Niger. So what mistake has she made? And the answer is that she hasn't placed them in the correct column. Because there was a 0 in the 1s, she left that one out. So instead, place the 3 in the 1s column rather than the 10s, the 4 in the 10s rather than the hundreds, and the 2 in the hundreds rather than the thousands. And this changes, obviously, the answer completely. So her correct answer would be 7,290. So let's have a look if this gets more complicated. Because if our thousands is going to exchange into the next column we need is the 10,000s column. Now we know this from the place value work we've done before, so it's nothing new to us, it's just using it in a new way. We do this exactly the same way we've always done it. We can do our 3,000 times 5, we can put them into our place value chart, much like we know. We can set up our compact method, which is here, and then we do our different bits as we go along. So the first thing is we do our 1s, we do 4 times 5, and you can see we got there, we need to make some exchanges. So we take the first 10 out, change it into a 10. We take the second 10 out, and we change it into another 10. That leaves nothing in our 1s column, but 2 extra 10s. So we make sure we've got our 20 written like this with the 2 extra 10s here. Then we're going to do 5 times no 10s. I hope you're screaming at the screen now going, but Mr. Burford, 5 times nothing is still nothing. And you're indeed entirely correct. This is probably the easiest part of the step. When you're timesing by nothing, the answer is nothing. We just need to add those 2 extra 10s which are in that column to the nothing that we have. So that column is just going to be those 2 10s. Then we do 5 times 5. And as you can see, we have loads there. So we need to make some exchanges. So we take the first 10, we pull it out and make that into 1,000. The second 10 of hundreds, we pull out, make into another 1,000. That gives us 2 additional thousands and 5 less in the hundreds column. And there we go. You can see the 25 written like this, but you can also see those 2 thousands we pulled out and the 5 left in the hundreds column. And then we move on to the thousands column. We do 5 times 3. So we got 3 here, 5 times, and those 2 additional ones down the bottom. Now in this case, we need to make some exchanges. So 3 times 5 is 15, plus those additional 2 is 17. So we can take out 10 of those and exchange it for 10,000. So we carried that over, put how many we have left in there, which is our 7. We've got 1 in our 10,000s column, which just is transferred up. So our answer is 17,520. This is probably the bit that people tend to get wrong when they move to this, because it feels like a large number, but actually the method is the same. As long as you only are thinking about one step at a time, actually your chances of making mistakes are relatively small. And that's the trick to it. You have to think about each step in itself rather than thinking about it as a whole. As soon as you think about it as a whole, it becomes very complicated. You're holding a lot of numbers in your head. If you think about it in each step as you go along, actually the maths involved isn't as hard as you think. So have a go yourself. We've got our first couple of calculations using any method you like, 4 digits by 1. We've got Ron thinking he's done his sum. Do you agree with him? Did you think he had to use the column method? Was there a quicker way, and what's the real answer? In the second one, in number 6 over here, we've got each digit card once to write a multiplication. So you use them in any order you like, fit them into the grid over here, and then complete the calculation. How many different products can you find? How many different products remember the answer of a multiplication question? And which one, what is the product that's closest to 8,000? It's a really nice question because there's lots of different ways you could think about where you're putting them and how you're sorting it out. And then you've got number 7, which is work out these multiplications and then thinking about what you notice about the answers. Pause now and have a go at them, and then I'll give you the answers at the end. So here we go. The answers. The first couple hopefully are relatively straightforward. Probably the most trickiest is C here because of that carry the exchange into the 10,000s column. But hopefully you're happy with the way in which you go about doing those. Ron, poor Ron. I hope you all threw your hands up in disbelief at Ron's mistake. Oh no, how could he possibly do it? When you times something by nothing, well, there's nothing there. Whenever you times something by nothing, it's still 0. So do we agree with Ron? No. When we times a number by nothing, we have nothing. So the answer is going to be 0. Now, number 6, you could have worked out lots of different ways of doing this, but the answer that eventually comes out being closest to 8,000 is 4,135 times 2. And I would probably say the easiest way to think about this is thinking about 4 times 2 is closest to 8, and then making the number as small as possible to go over that by as little as possible. Finally, you'll work out the multiplications down the bottom, and what you'll notice is that each time they double. And the reason for that is that 2 here, what we're timesing the top one by, times by 2 is 4. And 4 times by 2 is 8. So it makes perfect sense that they would be doubled each time. I hope that lesson was okay for you. If you do have any questions, bring them to the live session and we'll talk it through. Good luck, and I'll see you in the next lesson.